Welcome to the demonstration video DyMMer-NFP. In this demo, I will show how to model non-functional properties and multiple context adaptation scenarios in software product lines in DyMMer-NFP. In the first task, we will export an XML file from the Exploit repository. In the Exploit tool editor, we selected a software system feature model DyMMer Mobile Tool Guide. So, DyMMer 2.0 receives as input XML files, and it creates in memory a feature model representation. These files contain a header and the feature model relations. The header contains information about authorship, such as authorship contact and affiliations, beside the feature model creation date. However, the header information is not mandatory and it can be left in blank. The body of the file is mandatory and it comprises the feature model structure and its integrity constraints. After this, we will present how to import a feature model for addition. The second text, we will present how to specify the quality feature model, inserting the values of age characteristics, quality subcharacteristics, and non-functional properties to the quality feature model. Those values are specified according to the non-functional properties catalog and represent visual in the tool. In DyMMer 2.0, the addition of the quality feature model is represented by a hierarchical list. This area, quality feature model editor, is where the quality feature model is specified. The detail of the quality feature model can be accomplished by adding the characteristics and subcharacteristics of quality and the non-functional properties. They must be met for the domain of the product line under analysis. The third task, we will present how to define the context adaptation scenarios. In DyMMer 2.0, and context adaptation scenarios are added in a hierarchical list, where context information are added with their quantifiers and qualifiers, are inserted into a specific feature model without context. This area is where the context adaptation scenarios are specified and defined. Once you add a context information, you can specify its variation. This variation can be specified by means of quantifiers. These quantifiers are defined by relational operator greater than, less than, greater than or equals to, less than or equals to, equals, and different, followed by a value of type string, integer, float, or boolean. If this quantifier is defined by a numerical range, a logical operator is added, then can be of the type or AND, followed by another value of the type string, integer, float, or boolean. The fourth task we will show as analyze and specify the constraints between features and context adaptation scenarios. These tasks are meant to verify which features should be activated and the activates based on the activate context adaptation scenarios definitions. To perform this task, we will activate and deactivate features according to the context adaptation scenarios in addition. The fifth task we will show as specify interdependencies constraints between non-functional properties and features. Once defined which features are activated and deactivated for each context adaptation scenarios, the interdependence constraints between non-functional properties and the context features can be specified and represented in the quality feature models according to eight context adaptation scenarios can be specified. Thus, for which feature is activated and deactivated, it must be specified which contribution links a feature has in relation to one or more non-functional properties when this feature is activated and deactivated in the current configuration of the feature model. Plus, the feature is completely satisfies a non-functional property if it is activated. The feature does not comply satisfy a non-functional property if it is activated. Plus, the feature has a positive influence on a non-functional property if it is activated. The feature has a negative influence on a non-functional property if it is activated. Finally, the sixth task we will show how to visualize the SPL feature models configuration.